Today we will be taking a look at fractional replication of experiments. When performing statistical experiments using factorial design, these experiments can grow in size quickly and are often impractical to replicate on a large scale. Fractional replication of experiments is done when you have limited resources, whether it be time or materials. Using fractional replication, we can reduce the size of the experiment and estimate the effects of some of the treatments based on similar treatments. However, by doing this, you lose some of the accuracy and specifics of the experiment, so there are some sacrifices that come with implementing this strategy. Let's take an experiment where we have to test several different parts of a system. We have an internal combustion engine that has three systems: spark plugs, intake valve, and exhaust valve. We want to test the functionality and endurance of these systems under two conditions: low fuel and high fuel. Let's call these three systems A, B, and C. Unfortunately, we do not have the resources to run the proper amount of trials, which in this case would be 64. As a result, we will have to do a smaller analysis with 4 treatments. This means that we would use the results of the 4 contrasts to approximate the other 4. This would cut our resulting tests in half, from 64 to 32. We would first take a look at the table of coefficients for a 2 to the third factorial experiment. By looking at this table, we will choose a defining relation which we will use to eliminate half the treatments. You usually want to choose a higher order interaction. In this case, we will use ABC. We will then sort the table by the contrast ABC and eliminate the treatments 0, AB, AC, and BC, which all have the same coefficients in the ABC interaction. By doing this, we are left with the 4 remaining treatments A, B, C, and combination ABC. When we multiply the A treatment by the ABC treatment, we end up with the BC treatment. This means that A and BC are aliased, and we can use the A reaction to estimate the BC reaction. However, interaction ABC cannot be estimated accurately, which is why we used it as our defining relation. We will also be estimating the control effect 0 using the interaction ABC, which may not always be a correct assumption. Despite the possible error, fractional replication is still a useful tool for engineers who want to take advantage of a 2 to the k factorial design, but do not have the resources to complete a full factorial experiment.